Okay, everybody on Zoom. Let's see. I want to share screen. That's what I want to do. Share. Now. All the technology loading.
Ma'am, my eye clicker is not working.
What's not working?
My eye clicker.
Are you in class or on Zoom?
I'm in Zoom.
I just started class, but I haven't started a question yet. So let's see if attendance will work. Remove this. Okay, so try it now.
It's still not working.
Still not working. Did it work in the test class for us? Did you and I try the test class?
No.
Okay. Tomorrow, would you make an appointment with me tomorrow morning and we'll figure it out with the test class? It's probably that you didn't actually activate the subscription. You can try right now. You have to go to iCloud on the browser and log into your iCloud account. And then that email that you got with your subscription code, you have to put that in and update your account.
Okay.
Try that if you can get it going before class. But if you can't, make an appointment with me in the morning and I'll walk you through it.
Okay, thank you.
All right. Okay, let's see. Wait, I just did that. Right? This is what I want. Okay. Okay, so y'all want to hear a good joke? I've been telling, so y'all know, I tell y'all this, I put my son a joke in his in his lunchbox every day. That's like my job, right? So I started telling some jokes. Well, that means that other people tell me jokes. So they had a better one than me. I really like this one. My son was not impressed, but that's my son. So what do you call a bear with no teeth? A gummy bear. I thought it was great. So I'll tell you the one. So this is what prompted. Okay, so I'll tell you my joke. That joke was infinitely better than my joke. This was my joke. What is the most colorful snake on the planet? A rainboa constrictor. You see, I didn't even laugh. Y'all didn't even laugh at mine. Y'all laughed at theirs and not mine. I see how it is. Theirs was better. Theirs was a lot better. And Lillian, it's not a handheld clicker. It's a but you're saying the handheld clicker doesn't work from home. Okay, well that's good to know. Good information. It's so nice to see people. I feel like we've been virtual for so long. I know it wasn't that long, but it feels like it was a long time. Okay, so I think we ready to start? So I have a few things that I want to talk to y'all about in terms of the schedule. So if you have not already, go ahead and check in on iClicker attendance. I'll leave it up for a few minutes while I go over the schedule, and then I'll take it down when we start some clicker questions. So you go to our Moodle site, right? Everybody know where to get to our calendar? Our calendar's right under the syllabus. So click on the calendar. All right, here's our calendar, right? See if I can scroll over. This is really big. Let's see, view here. Let's do that. Okay. So where are we? We're over here. Okay. So we are on part 2 of chapter 4. Oh, look, and I can't even spell section. That's so sad. Let me fix that. That will drive me crazy. Maybe. Oh, it won't let me do it because I'm not logged in as me. Okay, I'll go back and fix it. But we're here on part 2. So that means that on Monday, what do you have due? Homework. But remember, because of the hurricanes, all that kind of stuff, I extended your chapter 3 homework to this Friday. So tomorrow by 9 p.m., you need to have your chapter 3 homework done. I noticed that a lot of people still don't have it done. That's not good. Please, please, please finish it. I will not, and I will repeat this, I will not be extending the due date for chapter 4. So you need to make sure you have it done. Okay? And if you have questions, please don't wait until 8 o'clock p.m. to email me your questions on Monday night because I might not see them. All right, let's see. So on Tuesday, we're going to start chapter 5. But I thought long and hard about it, and I decided that instead of splitting chapter 5 up on the exam, I would just put it on the next exam. So our next exam is going to be exam 2. It's going to only cover chapters 3 and 4. So our next exam after that, if we scroll over, is going to be chapters 5, 6, and 7. So the next exam will have 3 chapters on it. Okay? Yeah? Instead of having to split it up. I just didn't want to do that because you didn't have time to have all your homework done and submitted and all that kind of stuff. So I just thought that would be better. So please notice that because we're having the exam on Thursday, that's going to mean that part 2 is on Tuesday. So your homework, instead of being due on a Monday, will be due on, and that's wrong too. I got to get rid of that. Oh, I got to go back and fix it. I thought I fixed it all. Lesson learned. All right, so, but your chapter 5 homework will be due on Wednesday. All right, so I'll go finish fixing this after class. All right, let's see. Any questions from you guys?
Is it going to be about 60 questions like last time?
Yeah, it's going to be about the same length as last time. Yep. Same sort of questions, all multiple choice, right? Same sort of deal. And your exam is still going to be on Thursday, but it will not have chapter 5 on it. Work out for y'all? Okay. All right. And then you will have some extra material on your the extra content where I gave you a periodic table, the element names, the metric conversions, the formulas, and then I'll also give you like electronegativity values, things like that. Okay. All right. So let's get started. We need some clicker questions, right? So you need to check in if you have not checked in. And I'm going to go ahead and stop that poll so that we can do our clicker questions. Let's see. Can I hide this? I have the notes up on my computer screen on the side, so I'm not ignoring y'all in the chat. I'm just looking at it someplace else. I want to hide that. Okay. View. There we go. So, ready with your clickers? Let's get some more clicker points. All right, so select the inorganic compound. Select your inorganic compound. I'm going to call it at 1 minute. Okay, you need to check in if you haven't checked in. Come on, y'all. 1 minute. I know we had like 80 people on the sign-in, so please respond, everybody. All right, I'm calling it. Okay, so what do we say? Select the inorganic compound. So which one of these is inorganic? Majority of y'all had it correct. So how come it's inorganic? Why is that one inorganic? I thought organic had carbon in it. So why is this one inorganic if it has carbon? What's up with that? Well, more than that. More than that. What makes something organic? Is it just carbon? Carbon and hydrogen. So we see carbon and hydrogen in an organic compound. NiC, organic compound. Proteins have carbon and hydrogen in them. How about this one? Anybody know what that is? C6H12O6. Sugar. Sugar has carbon and hydrogen in it. DNA has carbon and hydrogen in it. Gasoline has carbon and hydrogen in it. Gasoline, have you heard this before? Is a hydrocarbon. Yep. So it has carbon and hydrogen. So B is our only one that is inorganic. All right. Ooh. How many carbon-hydrogen bonds are present at the indicated carbon? So just at the one that's being pointed out by the arrow. How many carbon-hydrogen bonds? 10 seconds. Okay, so if I were going to draw this carbon right here, I would put a carbon, and then what do I have coming off of that carbon coming down? That's a C what? CH2, and then what's here? A CH3. Okay, now what's coming off from the left? I have a C here, right here. I have a CH2, and then what do I have here? CH3, okay. So now what's coming off from the other side? Same thing, CH2, CH3. So look at that central carbon. How many more hydrogens can I put? How many total hydrogens can I put on there? Only one to complete that octet, right? Carbon now has 2, 4, 6, 8 valence electrons. So how many can you put on there? You can only put on 1. So majority of y'all said 3. Well, those aren't, these 3 bonds here, are these, I don't know what I did with that. I don't know how, oh my gosh. All right. The bonds that are coming off of here, this is carbon, 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 carbon. So there are 3 carbon to carbon bonds, but there is 1 carbon hydrogen bond. So be careful that you understand the difference in a skeletal structure. The lines are always telling you that it's going from carbon to carbon, or if I had an element at the end of this, if I had like, let me erase this. What if I had an oxygen here? Then that would tell me it's a carbon to oxygen bond, right? But if there's nothing there, I can assume that that element at the end of the line is a carbon. So be careful that you understand what those line diagrams mean. All right, let's see. We said that. Okay. So identify the correct skeletal line structure for this compound. If I'm trying to find a matching structure, my hint to you is to count your carbons. So count your carbons and see which ones match up. Oh, it's kind of, hold on, it was kind of, can y'all see it now? I'm sorry, D got cut off. Can y'all see it on the screen well enough? You want me to reset the question? Or is it okay? I'll give y'all an extra 20 seconds. All right. So if you haven't chosen something, choose something. Here we go. Oh, we have 81 now. Okay. All right. So how many carbons do I have? What is my longest chain of carbons? So here's 1. So I have 1 carbon, 2, 3, 4, 5. 5 carbons. And then coming off of those 5 carbons, I have a 1 carbon group and a 1 carbon group, right? What do we call those groups? Methyl, methyl groups. Remember that? So if I'm trying to count that, I want to look at my line diagrams and figure out which one also has the longest chain being 5 with 2 1-carbon branches from it. So you can start anywhere in the molecule, but you should start where the groups coming off are going to be closest to carbon 1. So if I look at A, I want to start here for my 1. So 1, 2, 3, 4, 5. And at position 2 and position 3, I have a methyl group. Is that true? At position 2 and position 3, I have a methyl group. Yes. B is a straight chain, so that's not gonna be it. That should have been an easy one for you to eliminate. C has a 2-carbon branch coming off of it. There's no 2-carbon branch here. So you cross that one out, right? And then D has the 2 methyl groups on the same carbon, and that's not what we see in the structure. So be careful with that. But good, most of y'all got it, good. Okay, so it should have been A. All right, I gotta scroll down just a little bit before I do it. Okay, which structure represents C5H10? Okay, well, I should have called it at 1 minute. Come on, y'all, ring in. Okay, so which structure represents C5H10? C5H10, what do you notice about this formula? If our number of carbons, 5 is our number of carbons, right? If I take that and I multiply by 2, I get 10. That's my number of hydrogens. So what does this tell me this molecule has to be? It has to be a cyclo, right? It has to be a cyclic ring. Well, there's only 2. What's the difference between the 2? B is a 1, 2, 3, 4, 5 carbon ring. And D is 1, 2, 3, 4, 5, 6, a 6 carbon ring. So what's my correct answer? It is B. Good. Okay. All right, now we're going to talk a little bit about fatty acids. So why are saturated fatty acids at room temperature, why are saturated fatty acids solids at room temperature while unsaturated fats are liquids? So remember, like butter is solid at room temperature, but olive oil is not, right? So tell me about those saturated and unsaturated fats. be on until 1:15. Okay, so tell me, before we answer this question, tell me about saturated fats. Why do we call them saturated? They're only carbon-carbon single bonds, right? They're single bonds between carbons. So what are they saturated with? Why do we call them saturated? They're saturated with hydrogens. That's right, they're saturated with hydrogens. Okay, so tell me about unsaturated fats. They have what kind of bonds? They have double bonds in them. So can they have the maximum number of hydrogens around them? You put another carbon, no, right? An unsaturated, how many carbons can, let's do my second carbon. How many hydrogens can be on that second carbon? Only 2. How many can be on the second carbon of my unsaturated? Only 1, right? So saturated fats have double bonds, making them less reactive. True or false? False. Saturated fatty acids have single bonds. Unsaturated fatty fats have double bonds that would create a bend in the chains. That's exactly right. So whenever you have those fatty acid chains, right? If you're saturated, it's the same thing over and over again, and they fit together like pages in a book, right? But what happens if you wrinkle one page in your book? And you wrinkle it and it goes up here, right? Because you get a double bond. Does your next page fit perfectly? No, it doesn't. So the unsaturated fats have double bonds that create a bend in the chains. So that part is correct, right? And so then the last one, right? Unsaturated. I guess I don't want to cross it out, but I just want to change that one to unsaturated fats cannot line up one next to another. So they are liquids at room temperature. Okay. All right. What kind of bonding arrangement is found in an alkene? ENE. And then we're going to skip over and go do some problems. Come on, y'all. I'll give y'all 1:15. Okay. So what kind of bonding arrangement is in our alkene? You should have said a double bond. Good, a double bond. What kind of bonding arrangement is in A? What would we name that? Not an alkene, but an alkane. A-N-E, right? Single bonds, A-N-E. What about a triple bond in B? Alkyne. It sounds like an I. Y sounds like an I. Alkyne. How about D? This is cyclo. That is correct. What else could you tell me? Do you have any double bonds or triple bonds? No, so it must be a cycloalkane, right? It goes A, then it goes E, then Y. So they go alphabetical. So alkane is a carbon-carbon single, E is a carbon-carbon double, and Y is a carbon triple carbon. That's kind of how to remember them. Goes alphabetical. But it's not alphabetical with the first letter, right? There's your A, there's your E, and there's your Y. Okay? All right, let's switch over. Let's go do some problems. See if I can do this. All right, I want, oh, did I not open that one yet? I might not have. Too much going on. Here we go. So I know y'all had a lot of videos to watch, but I thought that would be easier with everything, all the craziness with the hurricane going on. So try to stay up with those videos. They're gonna help you out. Okay, so I think we were on, oh, what page is that? I don't even know. We finished 4.3 in the video, right? Okay, so we finished 4.3, so we're looking for 4. Oh, there it is, 4.4. Okay, nomenclature of simple alkanes, right? So give the correct name for each of the following substituents. What's the difference between a main chain and a substituent? They're two different things. You can yell it out or you can put it in the chat. How do you know that something is in the main chain versus something is a substituent? If it's not carbon, is it a substituent? Yes. Yes. So if it is not carbon, so substituents are not carbon, that's one thing. But you can have substituents that are carbon-based. So how do you know it's a substituent and not a main chain? Y'all did watch the videos, right? Yeah, good. How do I identify a main chain? Put it that way. It's the longest stretch of carbons. So it is not carbon and not in the longest stretch of carbon. Right, so if you go up and just look at the one above, here's my main chain. See how long that is? That's my main chain. And then this would be my substituent in red because it's coming off of that main chain. Okay. All right, so give the correct name. What's my little mnemonic? Y'all remember? Me eat peanut butter. You sound like a caveman. Me eat peanut butter, right? but it stands for methyl. What else? Ethyl, propyl, and butyl, B-U-T-A, butyl. Okay, so CH3, CH2, which would be 1, 2, 3, 4, right? So would be ethyl. The next one, how many we got? How many carbons? 4, so it must be butyl. Why do we say butyl instead of butane? Because it's a substituent. So because it's a substituent, we're going to end the name in YL. And then I kind of wrote over it, but C is I. Iodo. Iodo. Oh, that reminds me. I don't know why that reminds me. But there was an error in the publisher's question at the I think it was one of the last questions in the chapter 4 homework. It asked you to take some compounds and to sort them as cis or trans isomers. And it put one compound twice and put that same compound in both categories. So you'll notice in the homework, I gave you full credit on one of the questions. So where you had to sort it, where you will sort it, you already got full credit. But there's one that's wrong, okay? All right, let's see. My brain jumping all over the place, okay. So next one, here we go. Oh, I can make that smaller, right? Okay. Draw the skeletal structure for each of the following compounds. So, how am I going to do this? When you're doing this, what do you look for first? I want to look at my main chain. So, what do I know from this? I'm going to have 6 carbons. They're going to be all what? What kind of bonds? All single bonds. And then coming off of what? Carbon 3, I'm going to have an ethyl group, which is CH. It doesn't matter how you do it, but wherever the dash goes, you put the carbon that has less hydrogens. So you could do it this way. Either way is correct. Okay, so I need a 6 carbon chain. Let's start with that. 3, 4, 5, 6. So 1, 2, 3. Coming off of my third. Am I crazy with that? Coming off of my third, I'm going to have a carbon come down, and then what's going to happen? Is that enough? No, I need to put a second carbon on there. So that is 3-ethylhexane. Okay, 1-bromo, 3-iodo, cyclopentane. It sounds super long, but you got this. All you have to do is break it down and take it step by step. You've got this. So go look for the main chain first. Tell me about the main chain. Pentane, 5 carbon. Now, we know they're all going to be what? Single bonds. What else do we know? It's going to be a ring because it's cyclo. And then what? Carbon 1 has a bromine. And then carbon 3 has what? Iodine. So you could put a dash so you know that it's binding to the main chain. Okay, so we need a 5 carbon. So do I have 1, 2, 3, 4, 5. Does it matter where I put those numbers? Could I have started on any carbon? Absolutely, it's a ring, doesn't matter. Okay, but now that I have them numbered, I want to put them I want to put the right things on them. So on my first one, what am I going to put? A bromine. Is there a carbon coming off of the ring? No. Be careful with that. A lot of people will make that mistake. They'll say that there's a carbon here at position 1 and there's a carbon here, but there's not. It's telling you that the carbon on the ring is being bound to the bromine. So be very careful about that, about knowing how many carbons you actually have based on the structure. Okay, what else do we need to add? On carbon 3, we're going to put iodine. Okay, now let's do C. Always go to your main chain first. So what can you tell me about pentane? 5 single bond carbons, okay? How about the cyclo? It's a ring. Okay, now what about propyl? Why isn't there a number? Because there's only one and it's on the first carbon. So on carbon 1, I have a propyl group, but remind me, what's propyl? Remember me, eat peanut butter, it is 3. So this is CH3, CH2, CH2, and it's bound to the main chain. I guess I shouldn't put the dash there. I'll put it on the other side. Okay. All right. So now I'm going to draw the same ring that I drew before. If I can squeeze it in somewhere. And it's actually, they're actually supposed to be kind of tilted. Watch. I can do better than that. It's kind of supposed to come inward. Not very good either, but that's okay. I'm not an artist. Yeah, I'm really not an artist. Okay, so does it matter where you start numbering? No, it doesn't matter where you start numbering. So any one of the points could be 1 because we could take it and rotate it, right? So you pick any one you want, doesn't matter, 1, 2, 3, 4, 5. So coming off of position 1, what should I have? So that's 1 carbon, 2 carbons, 3 carbons. Good? Okay. Next page. All right, now we have to go the reverse direction. Now we have to start naming some stuff. So what do you do first? You find your longest main chain of carbons. Rings are easy because it doesn't matter where you start. So let's start at the top. 1, 2, 3. And always remember, me, eat peanut butter. I'll never forget that. All right, so what are we going to name this one? Let's start from the main chain. I always like to start from the main chain, whether we're naming or we're going the reverse direction. Always start with your main chain. So you have 3 carbons in your main chain. What are you going to be? Propane. And how did I know it was an ANE? It's all single bonds. And then what do I need to say about it? It's a ring, so we're going to call it cyclo. Cyclopropane. All right, let's look at B. You have to count your carbons. If you take your finger and you drag your finger without picking it up, and every time you meet a point, that's a carbon, that's another way to do it. I like to number them. I just like to number them. So where are we starting to number? Now we have, you could do this 1, 2, 3, 4, 5, and then either one, doesn't matter, would become 6. But you have to think about, you have a group here and you have a group here, right? So which group do we want? Oh, and we have a group here. Which group do we want to have the lower number? This group is a methyl, right? Because it's what? This is really CH3. We have another methyl, CH3. That's a methyl. And then we have, what do we call it when you have a fluorine? Fluoro. So what comes first in the alphabet? Fluoro. So we're going to want fluoro to have the smallest number possible. How do we do that? We have to start from the other side. So I'm going to erase my numbers. It's still 6, and that's still the main chain. But we're going to number them 1, 2, 3, 4, 5. How did we get, oh, I was like, wait a minute. 3, 4, 5. Oh, and I just changed colors, whatever. I don't know how I did that. All right, so now we're going to name it. So what's my main chain called? 6 is, oh, hexane. Whoa. Y'all right. Come on. Hexane, okay. And it's A and E because we only have single bonds. What else? Start with your lowest number. So 3 fluoro, put a dash, then what? Start with your lowest number. So you have a methyl at 2, you have a methyl at 5, for a total of how many methyls? 2, so we're going to call it dimethyl. So 3 fluoro, 2, 5, dimethyl hexane. It's just taking it stepwise and kind of double checking yourself. Okay. Now, when you're looking at your main chain and you have a ring, how do you know if you're going to name the stuff that comes off of the ring as the parent or the ring? What do you have to ask yourself? Which one has more carbons? Does the ring have more carbons, or do the things coming off of the ring have more carbons? So what do you think? I'm going to erase the fluoro because it's kind of in my way. Is it the ring, or is it the stuff coming off the ring? The ring. Oh, Sarah asked, when do I know to put dashes or a comma, or does that matter on the test? You put dashes in between the numbers and the words. If you didn't put a comma, that would be 3-fluoro-25-dimethylhexane, and that wouldn't make sense. So anytime you're listing more than one carbon, you always put a comma between the carbons. So it does matter. Yes, it does matter. And I think traditionally you actually put a dash there. Speaking of. So you put a dash between the numbers and the words, and you put commas between numbers of carbons. Okay, so we have our main chain is going to be our ring. Do I want to start my numbering here, or do I want to start my numbering over here? I need to pick either of the two that are close together, right? Because I want to give all my constituents a low number. So when I look, I either want to go 1, 2, 3, 4, or I want to go 1, 2, 3, 4, 5. Ooh, do I want to go that way? No, I don't want to go that way. So I want to stick with my red letters, right? So always count your carbons and give your carbons the numbers such that your substituent numbers are low. So 4, I'm going to go 5, 6. Okay, so how am I going to name this? What's my parent? Cyclo, and it's still 6, so cyclohexane. Still has only has single carbon bonds. Then what do we need to say? Each one of these circles is what? They're each one is a methyl group. So at what positions do I have a methyl? 1, 2, 4. Then what should I say? How many methyls? Tri, and I'm running out of room, methyl. 1, 2, 4, trimethyl cyclohexane. Okay. All right, isomers. Isomers are kind of cool. All right, let's see. Gotta find one we haven't done yet. All right, here we go. Determine the relationship between the pairs of the following compounds. Are they structural isomers? If they're structural isomers, they're different molecules. Are they conformational isomers, where they're the same molecule, but we just kind of rotated them? Or are they not related? So when I'm asked this, my trick is to name it. So how do I name the first compound in A? Remember, me eat peanut butter. B is 4. So this is butane. Now count our carbons here. 1, 2, 3, 4. What do we have? Butane. So what are they? They're the same molecule. So these are conformational isomers. If you name them the same thing, oh, we gotta, okay, wait, let's see. Whoa. So when it's blank, it's always methyl. When it's one point coming off, let's see. If there were 2 lines, yes, yes. So if you look here on B, you have 1 line coming off, so this carbon's part of the ring. And then the blue carbon is a substituent. So we would call this one methyl, because you only have 1 carbon. You don't see the hydrogens, it's just CH3. But if we look on the other side, here's a carbon, and we see that that carbon's attached to 2 carbons. So C and C. So this is really CH2, CH, whoa, CH3. So this one is methyl, this one is ethyl. Does that answer your question, Caitlin? Yes, okay, good. Y'all always flag me if I miss the chat, please stop me. Okay. All right, so let's try B. Let's try to name these. Could you look at this and tell me the answer? Why? What red flag did you see? This is a methyl, this is a methyl, this is a methyl, this is an ethyl. So when you're naming it, you're going to name the first one in B dimethyl something, right? And you're going to name the second one in B methyl ethyl, right? So you know right away it's not going to be the same compound, right? The other way that, the other trick that you could do is you could just count your carbons, right? If I count my carbons here, I have 1, 2, 3, 4, 5, 6, 7 total carbons, and I'm not numbering them in any particular order. I'm just saying how many total carbons. 1, 2, 3, 4, 5, 6, 7, 8. If you have a different number of atoms, you're not the same molecule. So these are not related. So if you notice that, you don't have to take the time to name it. Is that okay for everybody? All right, so let's figure out C. Do we have the same number of carbons? If I go 1, 2, 3, 4, and I go 1, 2, 3, 4 on my main chain, and then I have 5 and 5. So I have the same number of carbons. So y'all want to name it and see if it's the same? So I typically don't put a number on my side chain. So I'm going to go ahead and erase that. So the one on the left, what should I name that one? It's my longest chain of carbons. I have 4, so I eat peanut butter, B, butane, because it's single bonds. Then what comes off of the main chain? 1 methyl group comes off of the main chain. This one is part of the main chain. So you only have 1 coming off of the main chain, so that is 2 methyl butane. How about my next one? What's my longest chain? 4, so I call it butane. Well, my 1 group is where? Position 2, so this is 2 methyl butane. So what kind of isomers are these? Conformational. I'm telling you, if you name it, you'll know what kind of an isomer it is. Okay, let's try this one. Do you see something that throws up a red flag? I mean, I'll go through and do it. I'll go through and name it. But what throws up a red flag to you? Look at the first one. I have a main chain. Do I have any branches? Did I have to lift my pen up 1 time? No, I got 1, 2, 3, 4, 5 carbons, and I never had to lift my pen. How about the next one? Let's say I start here. If I go up, down, down. In my main chain, I have 1, 2, 3, 4 carbons. My 5th carbon here is a substituent. So what could you tell me about this without even naming it? Do they have the same number of carbons? Yes. But are we going to, if we name them, would they have the same name? No. So what kind of an isomer? A structural isomer. All right. It's only conformational if it's going to end up being the same molecule. So what would I name D? The first part of D, the first molecule. Oh, that was a 1. I was like, why do I have that? That's a 1. Hexane. What do I name the second one? It's not hexane. Pentane. Y'all, my hexane and pentane today. Pentane. Thank you. What about my next one? I have how many in the main chain? 4, so it is butane. But then what else do I have to add on here? 2 methyl butane. So do they have the same? They have the same name? No. But do they have the same number of carbons? Yes. Okay. Look at E. Not necessarily, because you could have a ring versus a straight chain. So your number of hydrogens might change. Yeah, be careful with that. Or if you have double bonds, things like that. Okay, what do you notice about E? You have different substituents. This isn't even like a methyl and an ethyl group, right? This is different elements. So if I wrote my molecular formula for these, would they be the same? No, they're different elements. They're different formulas. So they can't be related. They are not related. Okay? You all right on that? Isomers can be kind of tricky. Isomers can be kind of tricky.
I'm just a little confused on like the difference between not related, like, I don't know.
If you gave the formula in D for both of the molecules, you would have the same number of atoms for each of them. But what we did was we took this and moved it here to get the second one, right? So we put this molecule in a different conformation, and therefore it can behave differently, so we have to name it differently. But it's still, if we wrote the molecular formula, right, this would be CH3, this, well, let me erase, because I don't want to, I don't want to get that confused. So this would be CH2, 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 CH3, right? The next one, CH3, CH, because you can only have one. Then this one would be CH3, CH2, CH3. So add up your carbons in the first molecule. We have 1, 2, 3, 4, 5, right? Why am I starting with a big number? Come on. C5, how many hydrogens? 3, 5, 6, 7, 8, 9, 10, 11. How about the next one? We have 1, 2, 3, 4, 5 carbons. 3, 6, 9, 10, 11. Oh, it's 12. Oh, I was like, wait a minute. Sorry, H12. You do complex chemistry and they can't do simple math. Does that make sense now? So if you look at them and they have the same number of atoms of everything, then they're going to be conformationally different. But if I look at the molecular formula, it's the same molecular formula.
I was thinking it was just the same amount of carbons for structural. That's why I was confused.
Okay.
But I get it now.
Okay, awesome. And everybody okay on the chat? Okay. All right, let's see. Okay, now cis and trans. Let's see. Oh, did y'all think I left y'all enough room on this one? I tried to be good about it. All right, so remember when we talk about if things are cis or trans, right? If you have a ring structure, if you have a substituent that comes off like my arms coming off the ring, I can't flip it unless I would break the bond. And I can't break a ring. Then it's going to change the compound, right? So you can't break a ring and you can't break a double bond, right? If you have a single bond, everybody can rotate freely. But if I put a double bond in there, I can't rotate. I can do this, but I can't rotate without breaking the double bond. So if you're asked about cis and trans isomers, you're usually looking at a ring or you're looking at a double bond. Okay? Y'all all right? Okay. So what do we have in A? A ring or a double bond? We have a ring, right? Okay. So we want to draw two isomers for this. We want to draw a cis isomer and we want to draw a trans isomer. So looking at a flat structure like that, can you tell what's above and below the ring? No, it's flat. It's two-dimensional picture. How do we make our picture go from 2 dimensions to 3 dimensions? That same thing that we did, right? Going out of the paper and into the screen and that kind of stuff, right? So we're going to draw our main ring. It's a terrible ring. But we want one to go up and one to go down. So it doesn't matter how you think about that, if it's coming out or if it's going away from you or if it's going up or if it's going down, right? So let's say for my methyl group over here, I want that one to go, I guess, towards me, right? So I'm going to draw it solid. What would I do for my ethyl group? If I want it, well, I guess I got to tell you, do you want cis or trans? Which one are we going to draw? I should have said that. Let's draw cis. Let's make it easy. Let's draw cis first. Cis refers to same, right? So if we're going to, whatever way we do one, we have to do the other the same way. So we're going to draw a solid little triangle, and then you just draw another line coming out of that solid triangle. So this would be the cis isomer. How would I draw the trans isomer? Let's draw the methyl group exactly the same. What would I do differently with the ethyl group? I would do the little dashed thing, and then you have to make sure you put another carbon coming out, so you make sure that you have an ethyl instead of a methyl. So that would be what? Trans. Okay. How about our next one? It's kind of weird with this one. Something going on. I have a methyl group and I have a bromo group. What's weird about it though? They're coming off of the same carbon. So are you going to have one above and one below? You can't have that kind of an isomer. So you just say not possible. Not possible. Because they're on the same carbon. Because substituents are on the same carbon. Okay, how about this? We don't have a ring anymore, so what should we look at? Y'all awake today? We're looking at, no, no, I get it. So I'm looking for my double bond, right? If I don't see a ring, I'm looking for double bond. And so if you're looking at a double bond, put yourself an imaginary line along that double bond. So if I put myself an imaginary line, really I have a carbon here and a carbon here. This one has a hydrogen, right? 1, 2, 3, that one has a hydrogen. Then I have one and I have a hydrogen. So that's really what it looks like. So how many groups do I have coming off of my carbon-carbon double bond? I only have one group. This is one substituent. We don't call a hydrogen a substituent. So if you have one substituent, can you make a cis and trans isomer? Nope. So not possible. Gosh, Dr. B. Not possible because, why? There is only one substituent off of the carbon-carbon double bond. It's kind of hard to identify cis and trans isomers when you have a straight line of your molecule, right? When you have that molecular formula. So let's redraw this one. Start with your carbon-carbon double bond. Ooh. So I started with my carbon-carbon double bond. I want to draw this side first. What should we draw coming off of that carbon? We have two things. A hydrogen and a fluorine. What is coming off of this carbon? Do it the red carbon. What's coming off of the red carbon? A hydrogen, and then what? Yep. So this is our substituent, and this is our substituent. Okay, so we have a CH2, and then we have a CH3. So for this molecule that I drew, what kind of an isomer did I draw? This is my double bond. What kind of an isomer is it? I'm gonna have to do something to wake y'all up. Getting sad in here. What do we got? Here's the substituent, and here's the substituent. Substituents can't be hydrogen. So are the substituents on the same side or on different sides? They are on same side. So what do we call it? Cis. So now I'm going to draw this molecule again. I'm going to have my red carbon and my blue carbon. I'm going to give them a double bond. So which one do you want to keep the same? Keep one of them the same and we'll change the other. What should we keep the same? Let's do the red carbon the same. So I'm going to do exactly the same thing. Now what do we do with the with the blue carbon? This time we're going to put fluorine up here and hydrogen down here. We're going to draw our same little imaginary line through that double bond. Now where are our groups? Opposite sides. So the substituents are on opposite sides or faces. Sometimes we call it the face of the molecule. So this is a trans isomer. How many more do we have? Oh yeah, chiral centers, that's it. Questions about this one? And this is the one that the homework has a problem on, but I just gave everybody credit. Okay, so chiral centers. All right, so mark the chiral centers in the following molecules, if any, with an asterisk. Before we do that, let's define a chiral center. What is a chiral center? We have different, how many different? 4 different substituents on a what? On a carbon. 4 different substituents on a carbon. So let's kind of list on the side. I want to make a little cheat sheet. So not chiral. Here's our little cheat sheet. How do I know that a carbon is not chiral? It what? If you have to have 4 different substituents, what happens if I have a carbon with a double bond? Can I put 4 things on it? No. So if I have a carbon double bonded or a carbon triple bonded, these are not chiral. Make sure you highlight that not. This is not chiral. What else gives it away that it is not chiral? What if I had something that was this? Can this be chiral? Can I have 4 different substituents on something that is listed as CH2? No, because two of them are what? Hydrogens. What about a CH3? Nope, because it's got three hydrogens around it. So if you eliminate those things first, it's going to make your life so easy. Because the definition is for different substituents. So if you have two of the same, it's eliminated. Okay, so CH2OH, is that carbon chiral? Why? It's got a CH2, can't be chiral. Okay, what else could we eliminate? Well, let's kind of look down, and I want to kind of draw this out, right? I'm going to draw this carbon right here. So I have a carbon bound to an oxygen, then it's also bound down here to another carbon, and that has an OH on it, right? Then it comes up and it has a CH2OH, right? So do we have, and this is just a CH because then it goes down again, do we have anything that is exactly the same coming off of that central carbon? We actually have a hydrogen there. Nothing's the same. So this one is chiral, so we put a little asterisk. How about the next one? How about the next one? I have a carbon, it's bound above and below, and it's got an OH, right? So it's a carbon bound to an OH, come up, and we're bound to a carbon, right? Do we have anything that's the same? And I'm missing something. What am I missing? A hydrogen. Are any of those groups the same? No. Can you make a guess for me? What's going to happen? All of these carbons are chiral. And it's because this ring structure here is not all the same all the way around. There's an oxygen there. So when you're looking at what's attached to, let's say, this carbon right here, you have an oxygen going this way, you have carbon going that way. So you run into different elements and different combinations of substituents. So it can't be the same. If your ring is all the same, now that's a different story, okay? All right, let's go down. Let's do B, vitamin B. So are there any that we can eliminate right off the bat? The double bonded, so this is a carbon double bonded to an oxygen. This is a carbon double bonded to an oxygen. Those two can't have four, so they're not chiral. Is there anything else we can eliminate? If you really look at this, if we start over here, right, we have an OH here. This is a carbon. What's actually bound to this carbon? This is really a CH2. So could this one be? Nope. Okay, now I come down here. I have this carbon. It's got a methyl and a methyl. Uh-oh. Not chiral. Okay, so let me X that one out. Now I have this one here and this one here. Can these be chiral? Why not? Because this is really CH3 and this is really CH3. So if you have three hydrogens, are you chiral? Nope. So we gotta put an X on those. Okay. How about the one that's got the OH on it? Is that one chiral? Right, we got a carbon, it's got an OH. Then we got a carbon double bonded to an oxygen, a nitrogen. And then on this side, we go to a carbon and we go to an oxygen, a hydrogen. Do we have anything that's the same? Nothing's the same. So is it chiral? Yes. So this one, I'll do chiral in red. It's chiral. Okay. If we go down, nitrogen can't be because it's not carbon. How about the one after nitrogen? This is really, whoops, I want to be in blue unless it's chiral. So this is CH what? 2. The next one is CH2. So can they be chiral? So how many chiral centers did you have? Only one. So if you start eliminating things, you're going to find chiral centers. Okay. What do we have in our antibiotic here? I can automatically eliminate everything in this ring. Why? This double bond. So these are non-chiral. None of those are chiral. I'm going to go in and I'm going to eliminate any of my other double bonds. Those are non-chiral. Here's another carbon attached. Here's another one attached to a double bond. We don't have too many carbons left. Can you identify one more right off the bat that you know is not chiral? Attached to the sulfur, there's a carbon, but it's actually CH2 because it only has 2 bonds to it. So I can automatically cross out that one. How many carbons do I have left? I have one right here. I have one right here. I have one right here. Are any of those chiral? So let's do the first one. I have NH2 bonded to a carbon, carbon double bonded to an oxygen, and then here's a ring, right? And then I have also a hydrogen. Anything the same? Nope. So it is chiral. Okay, let's do our next one. We have carbon to a nitrogen. Then we have carbon to another carbon, double bonded to an oxygen, carbon to a C, to a S, to an N, and a hydrogen. And then we need a hydrogen on there. Anything the same? Nothing the same. So we're chiral. How about the third one? Carbon, we're going off to the side to that previous carbon. We have a hydrogen, we have a sulfur, and then we have a nitrogen. Chiral? Yes. It's easier to go through and eliminate than it is to hunt and peck. Go through and eliminate the ones that you know are not chiral. Okay, last one. I know I can eliminate my double bond, right? Tell me about the peaks. That's CH2, that's CH2. Eliminate both of them. I got any more carbons? I don't have any more carbons. I'm done, there were none. Okay, and I think that's it. Is that it? Yay! I did awesome. Okay, so exam next Thursday. Exam next Thursday. If you need help, please, please, please reach out. Okay, so I'm going to stop this in class. Oh, to figure out chiral, I'm not supposed to just look at the atoms. No, you have to look at everything that's attached to it. It has to be the whole group. That's a good point. So you are correct. I'm gonna end. Y'all have any more questions on the chat? Let me take this off. Y'all post them in the chat if you have questions.
So I remember you had mentioned something about this. So what would be your
No, I'm not gonna. You're only responsible for doing the impact names, for the real names. There are lots of compounds that have common names. Like, if you weren't in regular society, you wouldn't know that water was called water, right? So I'm not gonna make you responsible for that. So don't worry about that. It's the normal name you use.
if you get credit for number 6, I think.
Oh, let me look.
Unless I'm wrong.
I might not. Sometimes I just forget to click. Okay, so I don't think I have anybody on the chat. Okay, so I'm going to end the Zoom if nobody's got questions. I'm going to end.